the solution goes further into detail on what's happening here. So we have to basically just, I wrote here what happens with n plus 1 if it's a factor or not factor of k. If n plus 1 is not a multiple of k, then that means the remainder increases by 1. But if n plus 1 is a multiple, the remainder wraps around, which basically means that the whole sum decreases by k minus 1, where k is the divisor. And this is because modulos can go to 0. We can then organize this. Since it's in nines, we can basically sort this into the number of remainders, like the plus 1's remainders, and all the wraparounds, which just basically are 0. If we consider our first case, 8 plus 1's, and 1 wraparound, I'll use WA for short. Well, this value, 8 1's, that's going to result in a positive value of 8. But since you want to subtract a k, you want to subtract the number such that this balances out to 0. Well, 8 minus 8 is 0. So our wraparound value has to be equal to negative 8. And this case only is one way of doing things where n is congruent to 8 mod 9. But this can't be true because this implies n is congruent to 2 mod 3. Which basically is saying that a factor of 3 wraps around, which we know is not true. So this case is false, and we won't find any here. Second case, we have 7 plus 1's and 2 wraparounds. Again, by our same logic, this has to equal negative 7. Since there are 2 wraparounds, we can then set them in pairs of 9 accordingly, like for these. So sum of 9 is acquired, so 2 and 7 is sums to 9. 3 and 6 sum to 9. What's it called? 4 and 5 sum to 9. That's it for all these 2 numbered pairs. We can try testing all out to see if they work. Let's go with 3, 6. Well, this means that basically, just a forward note, if you're dealing with pairs of numbers, the modulo it's going to be congruent to is one or both numbers. Like, you take the 6 here, right? Rn would be congruent to negative 1 mod 6 or simply 5 mod 6, which is true in this case. And let's see here. Well, if it's 5 mod 6, this can't be right because until 1 mod 2, which basically asks for an extra wraparound. So we don't want that. That case is out of the box. Let's choose, say, 4, 5 if there are any values that we want. Well, this basically means that n is congruent to negative 1 mod 4 or 3 mod 4. And then same thing with the 5 here. N is congruent to 4 mod 5. Well, this 3 mod 4 implies 2 mod 3, which is a contradiction in itself, because one of these cases is saying that something wraps around, but the other is saying it doesn't. So this out. Let's go to 2, 7. Well, when you test this value seems pretty valid, because these have the perfect value of negative 1 and negative 6, because you subtract 1 to sum to 7, right? So if we have that, this is actually our only working value in our second case. So n is congruent to -1 of, well, since there are two of these numbers, we want to respect that, and basically we want to like find both of those numbers rather than one, because we want specific bounds for our numbers. So this is 13 mod 14. Basically means that our desired values have to be one value away from 14. Example, one value away from a multiple of 14. An example of this is the number 13, which is 1 away from 14. And if we go on and on to like third case, we have 6 plus 1s and 6 plus 1s and 3 wraparounds. Well, our only case is 4, 3, and 2. But these can get really messy and contradicting. And apparently, if you try to solve for the case of 4, 3, and 2, there will actually be very weird contradictions. So that's disproven. And further cases are proven. So we can just rule that out. And basically, we just want to find how much numbers in the bounds 2 digits, 0 to 99, are there that are one less than a multiple of 14. Satisfy these specific bounds. There are 2 of them, which are 13 and 97 if you solve for them. 2 is our answer for this problem.